Determine the normal force on the 10 kilogram mass in each of the following diagrams. Let's call this diagram problem A and this diagram problem B. Start off with a free body diagram, a force diagram rather, on each mass. On A, we have mg going down, normal force going perpendicular out. We have the components of weight going perpendicular and parallel to the plane. The blue component is mg cosine, and the gray component is mg sine. Now you're looking for normal force, which is a vertical force coming out of the plane. It balances the other vertical force, the component mg cosine. And so normal force equals mg cosine of the angle. The mass is 10. The angle is 37. So 10 times 10 times the cosine of 37. Cosine times 100, we can round that up to 80. In part B, you have weight equals mg going down, normal force going up. And I don't really know if there's friction or not, but that doesn't really matter because friction is a horizontal force anyway, and we're looking for normal force. Let's go ahead and give this 50 Newton force its components. You'll remember the blue is the adjacent side, so that would be 50 cosine 37, which is 40 newtons. And the gray side is 50 sine 37, which is 30 newtons. Well, normal force is a vertical force, so we would talk about two vertical forces going up equal to one vertical force going down. So normal force plus 30 equals the weight, which is 10 times 10, or 100 newtons. In this example, normal force is 70 newtons. In the last example, we have a mass of 10 kilograms in each of the following diagrams. Again, we're going to split this to a part A and a part B. Part A is the exact same thing we just did in part B up here. Only difference is there is friction. So let's re-examine what we had last time. We had weight equals mg, which is going to be 10 times 10, or 100 newtons. You'll have friction is fun going to the left. You'll have normal force going to the right. You'll have your components, which, if you remember, 50 cosine 37 degrees was 40 newtons going to the right, and 50 sine 37 was 30 newtons going up. If you recall, we had normal force plus 30 equals 100, and the normal force when we subtract the 30, right, the normal force was 70 newtons rather. Now that's not the answer because we're looking for the acceleration, but we want to get in the habit of trying to find the normal force first, because acceleration is going horizontally, and friction is a horizontal force that involves the normal force. So if you get in the habit of finding the normal force first when you have a friction problem, it'll work more efficiently. So now in the x direction, we're going to use Newton's second law, which says causing force minus opposing force equals ma. Well, the causing force is going to be your 40 minus the opposing force, which is friction, mu times normal force, and that's going to equal to MA. Divide the M, and we have 40 minus mu, which is 0.2, times normal force, which is 70 newtons, all over the mass, which was 10 kilograms. This would be 40 minus 0.2 times 70 is 14 over 10. Well, 40 minus 14 is 26 over 10 is 2.6 meters per second squared. In our last example, we've got this ball that's accelerating to the right. And the forces acting on this thing would be its own weight and tension going up the string. We need components of tension. So I'm going to go up, and I'm going to go over. And since those are two parallel lines right there, this 37-degree angle is the same as that angle right there. That will help us find our components. Since this is the adjacent side of tension, this side will be T cosine 37. And across the top, it'll be T sine 37. Again, let's get in the habit of doing our vertical forces first. Our vertical forces are balanced. We may be horizontally accelerating, but vertically we're not. So in the y direction, we're going to balance our forces. Forces up equal forces down. And we get T cosine 37 equals mg. Well, T would be mg over cosine 37, which is going to be 10 times 10 over cosine 37. So 100 divided by the cosine of 37 is about 125 newtons of tension. It's helpful to find tension first because now horizontally speaking, in the x direction, we have to use Newton's second law because we're accelerating. And so causing force minus opposing force equals mass times that acceleration. Now there is nothing going to the left, so there is no opposing force. But there is a causing force, and that would be T sine 37. And that's equal to MA. Divide away the mass. And A is equal to T sine 37 over 10. So 125 sine 37 over 10. It's roughly about 7.5 meters per second squared. Remember to write down any questions you're having regarding anything you did not understand in this video. Thank you.